is on air pollution and job search. It's joint work with my one of my PhD students, Mariette, and Juan. It's a former colleague of mine. He's now at MIT since a year. And Nico Pestel is a former colleague of mine from IZA. So as a general introduction, and I think maybe not all of you came across with that topic so much before, just let me introduce you to the topic by showing you that picture on the right-hand side, which shows you basically that gray bar is zoomed in into a human hair. Yeah, so that's the size of a human hair, and next to it you see these small red and blue bullets, and these are fine particulate matter pollutions, or fine particulate matters, what we call fine particulate matter pollution, of different sizes. So usually we categorize them into PM 2.5 and PM 10, which relates to the size of these compounds. The PM 10 is something that we usually inhale, and then it stays in our lungs and triggers some respiratory health problems. And while the PM 2.5 are the very small compounds, which are the most dangerous ones, because they do not stop in the lung, but they actually go to our blood circulation and even cross the blood-brain border and even go to our brain. So that has been shown by the health science literature. So these particulates have been found in every part of our body. What do they do? Well, they trigger some problems, in particular, as I said, respiratory and also cardiovascular health problems. So people have to go to the hospital or admitted to hospitals when they're exposed to high levels of this pollution. But they also restrict our daily life. It has been shown in the economic literature that it has an effect on our physical labor market productivity. We have studies on call centers, on judges who take longer to conclude on certain cases, etc. But recently, the economics literature also started to investigate the effect on our cognition. And the mechanism is here because, as I said before, these particles have been shown to also end up in our brain. And we know from the health science literature also that they change our mood, trigger depressions, etc. And what they also do, they go to the brain, and in the brain they are recognized as something odd, and and that's why the brain starts also some inflammatory reactions to these compounds, and that might these inflammatory reactions might impair our cognition, our cognitive performance. So we have studies on this from Israel on student exams. We have one of our own studies on chess players, where we looked at the performance of chess players being exposed to different levels of pollution. And also what we also have recently seen in the literature, in the economic literature, is that they also change our behavior. So that we change our risk preferences, our time preferences, etc. Yeah? So taking all this literature, we as labor economists thought, well, if it has an effect of our health, our physical activity, our cognition, behavior, etc., we should also expect to see a link between air pollution and job search. Well, from a policy perspective, that would be a very interesting channel to look at, because then it would hit the most vulnerable group in the labor market. Those who are already disadvantaged would be even more disadvantaged by being exposed to dirty air. Yeah? But that's basically the motivation of the study. Oh yeah, maybe one more word on where do these particular matter pollutions or particular matters come from. They are, of course, they can be created by weather, by dust, pollen, etc. But the main source is burning fossils. Yeah? So by heating engines, like in cars, traffic, and in particular industry and power plants. Power plants and wildfires are the main source of particulate matter pollution. So why do we expect, from a theoretical point of view, why would we expect that air pollution has an effect in the first place on the behavior or the job search success of job seekers? Well, that is based on a simple job search model, where job seekers look for employment, or they search for employment until they get a job offer, which basically leads to a higher utility of accepting that job offer compared to the utility of remaining unemployed. That the switching point when individuals decide to accept or decline job offers is determined by the so-called reservation wage, which is the minimum wage that a job seeker is willing to accept a certain job offer. Yeah. So if there, you can imagine the person receives every day certain job offers, and then the person also has a reservation, which is also flexible, that can also change over time. And then if there is a job offer that is above that reservation wage, people accept the job and exit unemployment. Yeah? So the reservation wage and the set of how individuals determine that reservation wage is key in order to predict when an individual is likely to leave unemployment or not. In addition to the reservation wage, we have the search intensity, which also has an effect on the ability to find a job, because if people just search more, there are more job offers that come in that they can evaluate. We also have to mention that there's an endogeneity between the search intensity and the reservation wage, in the sense that if the intensity is low, then this job offer arrival rate also goes down. So there are less job offers coming in, also affecting the reservation wage. Yeah, so individuals will probably reduce their reservation wage because they have less jobs to evaluate. Well, in that setting, we can think about the effect of pollution to make it a bit more concrete. So we say, if I talk here about pollution, I always mean this fine particulate matter pollution. So there are other pollutants, of course, like ozone, carbon monoxide, etc. But here in that study, we focus now on particulate matter pollution. So there is pollution. People are exposed just by daily variation to different levels of pollution. And this might have some effect on our search intensity, but also on the reservation wage of job seekers. What are the mechanisms? Well, if we first look on the reservation wage, we know from the literature that there is that pollution impairs our cognition, while that can have a positive or negative effect on the reservation wage, because the idea is that individuals are less able to overlook the labor market and also to self-assess their own ability. And that's why I have a wrong assessment of the market wages, and maybe might overestimate their own value, set a too high reservation wage, making it less likely that they exit unemployment. If the behavior changes, so for example, as I said before, people become more impatient or more risk averse. If there's more pollution, that is expected to have a negative effect on the reservation wage, because you just discount the future more, you value the present more, and that's why you are more likely to reduce your reservation wage, accept jobs as soon as they come in. You can make similar stories for the search intensity. If you have health restrictions because of pollution, you're less likely to search. You have the impaired cognition, impatience, a lower productivity. All of this goes negative on the search intensity. Overall, from a theoretical point of view, we cannot conclude whether this is going to have a positive or negative effect on the unemployment exit probability, just because we have this unclear or ambiguous effect on the reservation wage. Yeah? But that's basically the theoretical foundation of our research question, why, from an economic point of view, we would expect an effect at all between the two parameters. Are there any questions so far on the theoretical foundation, on the subject of the study? Good.
Yeah, I may have one. Okay, so recently I read a paper from Nature about the link between air pollution and prenatal mortality, and they studied other particle, PM2.5. And my question is, why do you specifically choose PM10? Is it because it is somehow proven that it increases, for example, our cognition more than other particles? Is it the reason of data availability, or?
No, that's a very good question. I also would have mentioned later when we come to the data, but now that you said it's so actually we are interested in PM2.5, as you say, because these particles, they go really deep into our body and in particular to our brain and trigger the effects that we have in mind here. however, in the monitors that we are used, and these are public monitors who are distributed all over the country, and we use Germany here. These are installed by government agencies. They, at this time, they only measured PM10. It was not so common at this time to measure these really small particulate matters. That's changing, or has been changing since the last 5 years, but in the period that we look at, it was not measured, or not measured for every sensor. Let's say there are single sensors who measured it. It's basically a data availability restriction here. But I have to say at the same time that PM2.5 and PM10 are highly correlated. So in our sample, so for those sensors where we have also PM2.5 measurements, we see a correlation of around 0.9. Yeah? So they are determined by the same sources, and also determined by the weather conditions, whether there's wind, rain, the air pressure, etc. Yeah, whether they stay in our altitude, which we breathe, or whether they go to the other altitudes. Yeah, that's why we use PM10, but only as a proxy for PM2.5, because this is what we're actually interested in.
Yeah. Okay, thanks.
Okay. All right, then the main findings, in case I'm not able to make it to the end. Well, observational, kind of in a descriptive way, we see that if people are exposed to high PM10 pollution, and as I said, we use this as a proxy for PM2.5 pollution, but let's say they are exposed to high levels of fine particulate matters, individuals leave unemployment faster, but they at the same time, they also reduce their reservation wages. So at the same time, they take the job that they find, but they end up with lower wages, compared to individuals who are less exposed to high level of PM10 pollution. That's observational. There is no causal identification yet at that point, but I'm also going to show you the results as a starting point for our motivation to look a bit deeper into the search behavior. And once we do this, there we also have a causal identification strategy. And I'm going to show you this later. But what we find is that high concentration, and in particular very polluted days, trigger a reduction in individuals' reservation wage. So people seem to adjust their reservation wage as a response to exposure to high particulate matter pollution. And that's really high, like in a daily average of 45 microgram per cubic meter. I see that as from a perspective from the Netherlands or Germany, these are exceptional days. I checked for Warsaw. Unfortunately, this is like your daily business. I'm going to show you some some data later, but this is like today, for today, this was the daily average, just to give you an example. And I'm sure you didn't notice. And that's a danger, because in Asia, in some cities like in China or India, it's so highly polluted. They have values around 200, 250 micrograms per cubic meter. And then this is something you can even see. You see the smoke. In Russia, or like you don't see it, but it's there. And it's there to a degree that it also harms you, not only cognitively, but it also vulnerable people, like older people, are harmed by these levels of pollution. Anyway, and what we're also going to show is that the mechanisms for this are adjustments in patients and risk preferences. That is our main finding. Okay, let's jump right into it. As I said, what we did first is we looked at a large sample of administrative data of unemployed job seekers, and we do this here on Germany just because we have very good data available for our purpose. We use administrative records on unemployed individuals, and we here just draw some entries into unemployment in 2005 to 2008. I write here fresh, because this is what we have in mind as labor economists if we talk about entries into unemployment. So people coming from employment and then they become unemployed for different reasons. But we don't want to consider individuals who have been sick for a long period and then now go back to the labor market, we just as unemployed, or people coming back from parental leave or coming from active labor market policy. So those we don't want to consider. We want to have fresh entries, like people that we think of as labor economists. We have a subsample of the full population. It's 5%. It's ending up with 140,000 individuals. And we observe those for 24 months after they become unemployed. Yeah? And we do this and we merge these data to data on pollution and weather conditions in the counties where they live. And that's, of course, another restriction that comes with the data availability, but it's more or less common practice in the environmental economics literature, that you have to take sensors who are only available at the county level. Usually you want to have it in the backpack of every individual, because that you really know to what pollution the individual is exposed to. But that's, of course, not feasible. So that's why usually people use more aggregate measures. And here the smallest unit we can do is at the county. But a county is a city. So a city of the size of Warsaw in Germany would be divided into 4 counties, I would say. No? Just to give you an idea what the county means. If you go to more rural areas, of course, the county overlaps a larger region, but also less inhabitants, of course. So we drew a radius of 30 kilometers in the center of each county, and then if there was a sensor within that radius, we could use that county. Yeah, so on average, we have, I think, we could use data for 80% of our counties. There were 20% of the cases where there was no sensor back then in the early 2000s. They were installed close to the county centers, mostly rural areas. Urban areas at this time already had, all of them were equipped with monitors and sensors. Then I mentioned that before, we use PM10 as a proxy for PM2.5 because it's just not available at all sensors at this time. And we have the monthly, then from these sensors, we can calculate the monthly average of PM10 pollution, but also ozone. Ozone is kind of a proxy for general pollution because it's a product of chemical reactions of different chemicals in the air that comes with sunlight. And that's why it's supposed to capture supposed to serve as a proxy for general pollution. We have information on temperature, humidity, rainfall, and wind for the same from the same sensors. Yeah, so we merge the 2 databases based on the county level. We know where the people live in which county, and we know the pollution and the weather conditions for each county. Well, the main problem here, and that mainly prevents a causal interpretation using the administrative data, and in particular creating evidence on transitions to jobs, is that we don't observe when exactly people search for jobs, and we don't observe when people accept jobs. In the administrative data, we only observe when they start a new job. Yeah? So the data are based on social security information, and then for this system, it's not relevant when they were searching for the job, but for the administration, it's only relevant when they start the job. So we have the information when people start the job. Let's say, as an example, there's a person who started the 1st of May. We don't know when this person was searching for a job. So that's introduces a huge problem here in our study, because we cannot merge the environmental data from a time perspective. We cannot precisely merge them to the administrative data. So what we need to do is we need to make assumptions. What we do here is we said, okay, we merge the pollution of the month before they accepted a new job, assuming that they were mainly searching and negotiating about this job in the month before they started the job. Yeah? And we have to take into account that these are mainly low-educated people from the unemployed workforce. So, and these vacancies that are offered to these people are usually filled on short notice. So they come across, they apply, and then they get a decision. So it might be relevant that we only use the last month. We also extended it to 2 and 3 months. We see that the effect of the pollution becomes weaker the larger we do this that window. So we decided to go with only 1 month before the new job starts. Yeah? But because of these imprecise merging, we can also in the end not make any causal claims, because there's a lot of measurement error, of course, involved here. Yeah, but that's the best thing we can do with the administrative data to evaluate the transition to employment. What we then do is estimate a more or less like a hazard rate model, where we have on the left-hand side, we have the exit probability to employment. So for every month, we observe whether individuals go to employment or stay unemployed. So a 0-1 decision. Once they go to employment, they are right censored. So we don't observe them anymore. And for the wages, we also observe the first wage in the first month of employment. No? Then we estimate that regression, where we have on the right-hand side our parameter of interest, which is the PM10 pollution. So the average pollution in that county where the individual lives in the months before they accept a new job. We have a couple of fixed effects for the months and duration of unemployment. That is kind of the baseline in the regression model, that you say in the first month you have a higher exit probability on average, the second month a bit lower, third month again a bit lower, etc., etc. We have individual fixed effects. Individual control variables to control the education, gender, household characteristics of these individuals. And most important, we have regional controls on the economic circumstances. So we know the GDP, unemployment rate, vacancy rate, industry structure, to control as precisely as possible for the local economic conditions. Why it is important? Because it might correlate with the pollution and with the exit probability of individuals. So imagine you live in an area where there is more industry, there might be more pollution, but at the same time, you might be more likely to leave unemployment. So it's kind of one of the biggest confounding factors that we have in these analyses, and we control for this to some degree. We have also other pollution to make sure that what we measure is really PM10 pollution and not other pollutants, and that's why we also include the ozone as a proxy for general pollution, and we control for the weather conditions, because that also determines the pollution value and might also determine the mood of individuals, and that's why the transition probability to other jobs. In addition, we have some fixed effects here. The most important is the county fixed effect. So what we do, how we identify this delta parameter here, is basically looking at the same county, and then over time you have some natural variations in fine particulate matter pollution. And this is what we exploit mainly for our identification, controlling for the time-varying regional controls. No causal claims here, let me make that clear. So maybe we get closer causality with this model, but we cannot make any causal claims, although we control for very rich set of confounding factors. Again, the PM10 measurement, we don't know for sure whether this overlaps the period of searching for the job. So we might pick up something else that is not due to the PM10 pollution, but because of something else, a confounding factor. But it will at least tell us something about whether there is at least a correlation between the pollution and something that happens in the labor market for job seekers. Well, if you run that regression on our administrative data, we see the following outcome. The first column gives you the exit to the results for the exit to employment. The second column gives you the effect on the wages in the first months of the new employment. We decided to have like these categories of PM10 pollution to see whether there is maybe a non-linear effect in the effect of pollution on search. Maybe there is no effect for low values, but a much stronger effect for higher values of pollution. And what we see is for the exit to employment, that throughout the distribution of pollution, that always has a positive effect on the exit to employment compared to the reference category of low or no pollution. Yeah? This suggests that there are people on average with conditioning and all the control variables that we have leave unemployment faster if there is either higher levels of pollution, and you see the effect is even increasing along the distribution of particulate matter pollution. Again, no causal claims, but it tells us something, that it seemed that pollution might have an effect on the exit probabilities of unemployed job seekers to employment. The second column and then tells us something, okay, they leave faster, but what is the consequence on the wage? We see that there is a negative effect, not throughout the distribution of PM10, but in particular for like middle or medium values of PM10, we see that there is a reduction in the wage of the first job. Well, what does it tell us? It suggests that there might be an effect in the search, a change in the search behavior, in the sense that people might adjust their reservation waging, also accepting lower paid job in order just to find employment faster, because of this adjustment in their behavior, in the impatience and the risk averse. Yeah. So that's of course something we cannot conclude from that table, not at all, but it's at least something that is suggestive in this direction. And what we do now in the second analysis is to look a bit deeper into this, to see whether we can find an effect supporting that observation in this job search behavior of individuals. Okay. Is that clear so far? Are there any questions on the administrative data or thing that is unclear?
I actually have a small question regarding this wage effect. So it's in comparison, you said, but I lost it. In comparison to the previous job, or this wage decline?
No, this is compared to other individuals in a county, in the same county, who found a job at less polluted days.
Nice, okay. Okay, so
so compared, you find a job in a period where there is pollution 15 to 20 micrograms per cubic meter, compared in the same county to a person who were looking for a job in a period where there was less pollution. That is a wage difference. It's 1% reduction in the wage.
I see. Okay, so it's between persons.
Yeah, it's a small effect in magnitude, but yeah. So it's you see it here. The mean of the dependent variable is 32 euros. These are daily wages, and then 1% to they earn per day €3 less. Yeah. Again, we cannot make any causal claims here, but this is what this coefficient means. So that's basically showing a correlation between the two variables, a conditional correlation.
I also have a small question, if I may.
Sure.
Maybe I missed it, but I would like to ask about the control variables in your model. Have you controlled for the number of job offers in the area?
Yes. No, not explicit. Yeah, not explicit, because that's something we don't observe. So we don't observe whether people, when jobs are offered to individuals, precisely, but what we measure are vacancy rates. So we know the number of available jobs in that region over all unemployed. And that is included in the regression as part of the regional control. It's kind of a vacancy rate.
Okay, yes, thank you. Because what I was like, from your results, I was thinking that maybe in the, I'm sorry for this chicken.
No problem, no problem.
Today. Probably because of heat, I don't know. So what I was expecting is that maybe in the areas that are highly polluted, there are more job offers, and that's why people enter or exit the unemployment sooner than
yes, you are absolutely right. I mean, that's also what I meant with the confounding factors that we are concerned about. There's something else happening in the same month in the economy that affects pollution and the job and the outcome at the same time. I totally agree. And we do our best to control for this by having detailed economic controls like the GDP, vacancy rates, and other things. But we can never exclude that there is something else that affects it too. And that's why the delta that we estimate here is because of something else and not because of PM. But it also could be that we also included the vacancy rate because we thought that also reflects a bit the demand side. So the pollution might also restrict the demand side. If there's high pollution, maybe less jobs are offered to also capture those effects. And that's why we explicitly put the vacancy rates. Yeah. But long story short, no causal claims here. It's only suggestive, it's correlations, although we control for as much as we can. But in the end, the rough measurement of PM10, the monthly average pollution over a complete month is might be a too crude measure to make any causal claims at all. Yeah, but at least it tells us something in terms of, you know, suggestive evidence. Yeah. So now we go dig a bit deeper and say, okay, if there might be something, so we want to look deeper into the heads of people, and if we want to look into heads of people, we have to say goodbye to administrative data, and we have to go. You know, you might also disagree with this, but at least the survey provides us a bit of opening the heads a bit. So what we then do, we had a subsample that I also was involved in constructing it when I was at IZA. What we did out of the administrative data, we drew a subsample of unemployed job seekers, and then we interviewed them quite extensively. So they received an interview of about an hour on every dimension of job search, their labor market activities, name it, whatever you can think of. And this provides a good opportunity for us now to look at detail on the job search behavior. And the big advantage compared to the administrative data is also we know the exact date and time, even the minute of the interview. So we can exploit, and we also have from the sensors, we also have hourly information on pollution. So we can much better link the pollution to our outcomes. Yeah, so before we had to make that assumption that the months before you start your new job, you have searched for the job, and we just, you know, match then the monthly pollution the months before to the administrative data. Here we can match exactly for every individual the exact pollution that individual was exposed to at the time of the interview. Yeah? Making it much more precise. And I tell you why this helps us with the identification. But for now, we have 18,000 individuals. We have this large interview survey. By the way, if you're interested in these data, they are publicly available. So you can just contact IZA and you can download the scientific use while working with it. So we use these 18,000 individuals for which we have these detailed information. We merge the same pollution and weather data, but this time we have hourly information. And we know the timing of the interview, so we can have a much better match in terms of the timing of exposure to pollution. Maybe it's worth to show this. This is just a distribution of the observed pollution in our estimation sample. And you see here the PM10 pollution in microgram per cubic meter, and the red dashed lines indicate later the categories that we use in the regression. Yeah, just to see, you know, what the support is in each of these categories, and even the highest category that we have 45 and beyond, so the most polluted days or hours, also have still some support in the distribution. It's not extreme. It's not only the extreme days, but it also happens sometimes. I show you later that distribution that is from 2008. I also show you that distribution for 2020 or 21 even, and you will see there's a huge shift to the left for Germany. So that it improved significantly over the years. Nowadays, you almost have no support anymore in that category. That I show you later. Good. For our outcomes in the survey, as I said, we want to look into the search behavior. For this, from the job search model perspective, there are two parameters which we are mostly interested in. It's search intensity, and it's a reservation wage. The search intensity is measured as the average daily number of applications sent since the entry into unemployment. So individuals enter unemployment, and then on average after 2 months they have been interviewed. So some of them in the first week, some of them after 3 months, but on average 2 months. And then they report how many applications they have sent since entry into unemployment, and then we divide this to the number of days they are in unemployment, and that gives us the daily number of applications, which we interpret as a search intensity. For the reservation wage, we have the exact hourly wage that they expect to earn, or that they would be willing to take up a job. That is a result of a couple of questions that allows the construction of the daily reservation, hourly reservation wage. In addition, we have a crude measure of risk tolerance and patience just on a 10 on a Likert scale of 10, asking them, you know, how willingness to risk you are from a scale from 0 to 10, and the same for the time preferences. Well, for the construction of to understand also later our results, we have the two main outcomes: the search intensity, the number of applications, and the reservation wage, and the risk tolerance and patience. First, the search intensity is measured, as I said, since entry into unemployment. We know, let's say that individual I was interviewed here on October 24 in 2007. And we know that individual entered unemployment on the 18th of October. So we know that individual has been unemployed for these 1, 2, 3, 4, 5, 6 days. Yeah. And because the question is asked of how many applications did you send since the beginning of unemployment, you also match the pollution, the average pollution overlapping that time span. Yeah. That is still a bit of a crude match because we don't know whether the applications have been sent here or whether every day there has been sent one application or all of them have been sent here. So it's still a bit of the same problem as we had with the administrative data, that we cannot really precisely match the pollution data. With the reservation wage, that is a completely different story, because the reservation wage is asked at the time of the interview. The same for the risk tolerance and the patience. Yeah, so they asked, like, what is your reservation wage now? What is your risk tolerance now, etc. So therefore, we can exactly, if they have been interviewed on the 24th of October at 10 o'clock, we can also match the same pollution at that day, or also the pollution of the day before at 10 o'clock to see whether there are lagged effects. Yeah. So now you see where I'm going. For the reservation wage and the risk tolerance and preferences, you might have a causal interpretation here, because we can exploit the random allocation of interviews to individuals. So individuals were called at random. So at the Survey Institute, they got, like, every month, they got 7,000 addresses and contact details. And out of the 7,000, they had to realize 1,500. So they started calling them. They tried to reach them 3 times. They couldn't reach them. They put them aside. Next one. They did this until they finished the 1,500 interviews. Yeah. So this gives us somehow kind of a random allocation of when people are interviewed. Of course, there might be still a bit of heterogeneity, because it can happen that people pick up the phone and say, oh, no, now I cannot have the interview. Maybe you can call me tonight. So they make an appointment. That happened for some of the observations. And in the sensitivity, we exclude those and re-estimate our results to see whether there is an endogenous, selection into the interview. But it's I can show you later the results. It does not change our results. So we can assume that the exposure to PM10, because of the randomness of the timing of the interview, is kind of random for the individuals. Yeah? So now let's say economic circumstances play a role. So that in the sense that they are confounding factors. So let's say the regions who have more industry have also more pollution, and that's why also have a faster exit to employment. This factor is less a threat here, because we don't expect that there is variation in the industry level on a day or even hourly level. Yeah, that is the main argumentation that we have. The empirical model is similar to the administrative data. We have our outcomes here for individual I living in county J at time T, responding to our survey. We can match, as I described, the pollution for the search intensity based on the period since beginning unemployment. For the reservation wage, risk, and time preferences, we measure it at time of the interview. We have, again, individual controls. We have some survey specific fixed effects like the month of the year, day of the week, hour of the day dummy to just, capture these general pollution effects. We have weather and environmental controls, and we have again the regional controls. And we have state fixed effects. Here we cannot use county fixed effect because then we have too little power in our analysis because we not always observe multiple individuals in the same county. This is how we estimate our effect, and we argue that better is mainly identified for the reservation wages based on the random timing of the interview. Whether you interview today or tomorrow or in 2 days, that is not at your discretion, but it's at the discretion of the interview company. And they, of course, do not endogenously select individuals, but they just randomly draw them out of the pool of available addresses. Well, what do we find? Here you see the main results that we have. We have it on the panel A on the left-hand side. We have it for the search intensities, for the different categories of pollution, like the 15 to 25, 25, 35, and beyond 35. And we have it for the reservation wages similarly, but here we have one more category because we have this hourly pollution. So we have more variation. We observe more extreme values compared to the search intensity, where we have the average PM10 since entry into unemployment, overlapping a larger time span, so we have less variation. That's why we have 4 categories. Yeah, also one with above 45 microgram per cubic meters. What do we see? For the search intensity, we see that if there's higher pollution compared to the reference, which is below 50 micrograms per cubic meter, we see throughout negative effect that is also, in terms of point estimates, also increasing along the distribution of PM10 pollution. Yeah? More pollution, that point estimate suggests if the period since entry unemployment has an average pollution of 35 microgram per cubic meter and above, reduces the search intensity by 30%. Yeah? 30%, the average search intensity is 0.3 applications per day. So it's 0.1 application less per day that they send out if they are exposed to higher pollution. This is how you interpret that picture. Well, that is the best we can do for the search intensity, in particular because we have this measurement problem that we have it only measured since the entry into unemployment, overlapping a larger time span. For the reservation wage, we see a similar pattern, but the less polluted days or the medium polluted days have no effect on the reservation wage. But if people are interviewed at highly polluted days, they report like around 4% lower reservation wages. No? This is how you read that figure. So now what I want to do is, as I said, we have this is measured at the interview. We can do more. We can also use a bit, play around with the temporal dimension. So we can use the variation that we observed just before and after the interview. So we take that coefficient here and disaggregate it a bit more. So estimate the effect of the pollution 1 to 4 hours before the interview, 5 to 8 hours before the interview, 9 to 12 hours before the interview, and so on. And we do the same for the leads. We also measure the pollution 1 to 4 hours after the interview, 5 to 8 hours after the interview, and so on. And that coefficient is the pollution at the exact hour of the interview. Here you see the coefficient from that figure, just as a comparison. That's the 24 average before the interview. Yeah? So what do we see? We do 2 things. One is a very good thing to see from an econometric point of view. The leads have no impact. Right? That makes us a bit calm down, saying, well, apparently at least there are no confounding factors who are correlated over time, because then we would also see an effect from the leads. Yeah, but from a conceptual point of view, we should not expect to see an effect at all, and we don't see it. That's a good thing. So that's kind of a falsification test. What we also see is that it's not the pollution that you are exposed to just before that affects your decision on the reservation wage, but it's kind of a lagged effect. So we see it that it's like half a day to a day before the interview. That is dominating the effect that we see on the 24-hour average. We also see that a lot of individuals are interviewed in the morning. So it might be that it's a pollution from the evening or the afternoon of the day before, where usually also pollution goes up much more because of rush hours, etc. So it's kind of a lagged effect for half a day to a day. That's what we see in that, what this figure shows us. As a last thing, and then I also go to the conclusions. And if I have time, I can also show you that for the restricted sample without the appointment, but it looks similar, less stars because the sample size of course goes down, but the pattern is very similar. The mechanisms. So for the reservation wage, if we see an adjustment in the reservation wage, and we know the reservation wage is also determined by people's time preferences because discount rates play a significant role. If you discount the future more, you might be expected to reduce your reservation wage more because you value the present more than the future. So you would also to see an effect on time preferences on patients. And you would also like to see something on the risk preferences because people who are more risk averse would also value the present more, and you would expect to see also that effect in the risk preferences. And what we find is also a very similar effect pattern compared to our reservation wages. Yeah? So apparently the pollution changes the behavior of people, like the assessment of the future, like discount rates, but also like risk factors. And that we argue might explain the effect on the reservation wage that we see. Yeah? So the consistent results in the mechanisms together with the falsification test makes us believe that there is indeed the effect of PM10 that we estimate in our regression and not the one of a confounding factor. But that, of course, we can discuss. But this is something how we argue in our study. So let me just say some words about the conclusions and the implications. Well, let me discuss. I just want to highlight again that it seems that in particular the very polluted days or hours play a role here. So if there is like average pollution that we have, in an average European country of around 15 to 20 microgram per cubic meter, this should not affect our economies or the searching behavior of unemployed individuals. But if we go to high values, it affects the job search effect of individuals. Well, that is our main finding. And before I draw some policy conclusions, I just want to mention that one thing we still want to do and what we're currently doing, and we're collecting the data right now, is we want to use the wind direction as also an additional IV strategy to predict pollution, to really be able to say, well, that is the PM10 pollution and not something else that is correlated with PM10 pollution and also correlated with our outcomes. So in addition to the falsification test, also provide additional evidence on the channel that we have in mind. Policy implications. So if it's only the high polluted days, well, why should we care? So it affects only maybe, in the Netherlands, a handful of days per year in the most urban areas. And for the rest, we wouldn't expect any effect on the unemployed given our results. Well, that's true. Nothing is wrong with this, but in particular, this is also shown here, the distribution that I mentioned before. The gray bars here is the pollution that we observe in our estimation sample in 2008. And that has shifted, as I already said, to the left distribution, to the red distribution, which is a distribution of PM10 in 2020 in Germany. And you see days of an average pollution beyond 45 and above is, you know, it's a handful of days in the county. So from a policy perspective, nothing to worry about given our study. Not about the unemployed, still people getting exposed to hospitals, triggering some significant costs in the hospital sectors. But from the unemployed point of view, nothing to worry. But if you look at a European picture, it's a different picture. There are still areas, in particular the northern of Italy, and sorry I have to say this, but also in particular Poland, is a point of concern here, because these are regions who are highly polluted in terms of fine particulate matter pollution. And not highly polluted in an international comparison, of course, so nothing to compare with Asian regions. But in a European context, these are very dirty areas. So you see, for example, like I think Warsaw is something like somewhere like here. You see there is a yearly average PM10 pollution of 40 to 50 micrograms per cubic meter. It's an average. So you can imagine you are always exposed to 45 and more. Yeah. While the yearly, just to give you an example, Germany and the Netherlands have a yearly PM10 average pollution. I have to think, but I think it's something about 1560 microgram per cubic meter. Yeah? By the way, the EU regulation is 25, so you are breaking European law, but you know that's a different story. But I think that's something they have to work on. But in these regions, our results say, well, that might have effect not only for the health sector, but also for the economy as a whole. Because if we can show this for the unemployed individuals, it would definitely also have an effect on the workforce, on the employed workforce. Yeah. Well, that's everything I have to say. I wanted to present. Thank you very much for your attention.